In this video, I'm going to talk about Dunnett's T multiple comparison test, which is one of the most powerful tests you can apply in the context of comparing treatments against a control. And that's the scenario where you're restricting the comparisons to only the treatment groups and the control groups, and you're not interested in any difference between the treatment groups. So in this example, we have a drug A group, a drug B group, and a control group. And all you're interested in comparing is drug A versus control and drug B versus control. You're not interested in drug A versus drug B or any other comparison. So in order to conduct this study, which is a fictitious data set where we have cholesterol levels, the bad cholesterol, and you're expecting the drugs to reduce cholesterol relative to the control group, we can go into Analyze, Compare Means, one-way ANOVA, and we put the dependent variable in the dependent list and the grouping variable in the factor list, and we click on Posthoc, and we've got Dunnett right here. Now there are two things to keep in mind when conducting a Dunnett t-test multiple comparison procedure. First is whether your control group or your comparison group, whatever it is that you're isolating, is the last group or the first group in your independent variable. So if you look at these data, the control group is actually the third group. Often the control group will be the first group, but in this case it's the third. And you have to keep that in mind when you specify the Dunnett t-test comparison procedure, because you have to specify which one is which. So Dunnett, and in this case it actually is last. The control group is last. Now the next thing you need to consider is whether you're doing a two-tailed test or a one-tailed test. And my overall recommendation is to typically do a two-tailed test, because I think there's questionable validity associated with a one-tailed test. But I'll show you the one-tailed test anyway, in case you're interested in doing one. And in this case here, you actually have to tell SPSS whether you hypothesize the control group to be smaller than the treatment groups, or whether you expect the control group to be larger. Because if it's a one-tailed test, you're specifying a direction. So in the cholesterol study, you'd expect the drugs to reduce bad cholesterol, so you would specify this option here. But first, let's look at the two-tailed approach. I've got last as my specification, which is good because the control group is the third group. And I'll click on Descriptives and Homogeneity of Variance Test. Click on Continue and OK. And we can see here that the means associated with drug A and B are not very different. It looks like drug B might be a cinch better, but that could happen by a chance. The control group mean is 129.5, which is numerically lower than drug A and B. So who knows? Maybe there is a statistically significant difference between the drug groups tested individually against the control group. Homogeneity of variance assumption is satisfied. Here's the ANOVA table, which you can't ignore because the Dunnett t-test is a single-step procedure. So we don't need to actually look at that. Here's the multiple comparison results, and we can see that drug A mean versus control mean, which is a difference of negative 23.5, is not statistically significant, p equal 0.115. Drug B versus control, so 105 versus 129.5, is a little bit bigger of a numerical difference at negative 24.5, and the p-value is still not statistically significant, p equal 0.098. So the null hypothesis of equal means has not been rejected here, comparing the two drugs against the control group. But what if we did a one-tailed test, which is controversial but still a possibility? Go into Posthoc. We expect the treatment groups to be less than the control group. So we click on Continue and we click on OK. And in this case here, we actually get a statistically significant effect between drug B and control, which has essentially split the original p-value in half because it's a one-tailed test. So doing the one-tailed test where we specify the treatment groups to have lower means than the control group, we actually found one comparison to be statistically significant. And I suspect that's why people are attracted to the one-tailed test, is that you technically get more power. And the question is whether you're inflating your chances that you're going to commit a type 1 error or not. That's the question. So that's how you can do a Dunnett's T multiple comparison, whether a two-tailed or a one-tailed. You just have to pay careful attention as whether your control group or comparison group is the last group or the first group.